But anyway, we're moving on. We're like I said, we're only covering sections 4.1, 4.3, and 4.4. And that's what will be on the test. And then next week we will have our test, and then we will do section 4.6 as well. Might be beneficial to do 4.6 before the test or not. I don't really care. 4.6 is kind of like applications of what we're doing. But it doesn't matter to me. It kind of would be a little bit of review so that you get more comfortable with it even more than that. But if you want to do it after the test, that's totally fine too. So we'll talk about that after we get done with this first lesson, and hopefully a few more people are here. So we're talking about, in section 4.3, we're talking about logarithmic functions, and then we're going to get to equations as well. A logarithm, we call it logarithm base b. That function is written log, and then we've got a subscript b. And that tells us that that's the base, that subscript of x is the inverse of the exponential function with a base b to the x power. So if you remember, we talked about inverses back at the very end of chapter 3. Inverses are functions that undo each other. Okay? And inverse operations undo each other, inverse functions undo each other. And so that's why we talk about exponentials, like we did last week, and logarithms, like we're doing now, in the same chapter, because they're what we use to undo them. Okay? Logarithms undo exponentials, exponentials undo logarithms. So that's why we're covering these. But here is a statement that we are going to use to our benefit. And these are the cancellation properties of logarithms. So if you've got log base b of b to the x power, anytime you've got a logarithm and an exponent that have the same base, those bases will just cancel out, and all you have left is x. Okay? Same thing happens over here. So again, either order, it doesn't matter. So here's your base of the exponent. Here's your logarithm. Notice they both have the same base. And so they're going to cancel out. And what you have left is the x. All right. So cancellation properties, they're going to be helpful for us. It makes the problems really easy if we can set them up this way. So this statement is probably the most important statement in the chapter right here. So this is something you want to highlight, underline, circle, put a star by it. I don't care what. But this is this right here is what we call logarithmic form. And then this is what we call exponential form. And that marker isn't great, but hopefully you can read those two. Logarithmic form over here has a logarithm in it. Exponential form is going to have an exponent in it. But here's the thing when we talk about logarithmic form. These two statements are equivalent. In other words, they're saying the same thing, but one of them is saying it in logarithmic form, and one of them is saying that information in exponential form. So here's the key thing, because what we want to be able to do is switch it back and forth between the two types of statements, from logarithmic form to exponential form, and then vice versa. So here's the key. Notice then in each one of these, whether it's in log form or whether it's in exponential form, the base is b in both of those. The base doesn't change. So anytime we're going to switch back and forth, we always identify the base first. And the base is this subscript number, or the base is this number that has the exponent attached to it. Okay, so the base is what we always identify first, because that doesn't change regardless of which form you're in. Okay, now the second thing is, notice which letter is by the base in this logarithmic form. It's the C, right? And the A is by itself. Which letter is by the base in exponential form? The A. And the C is by itself. So what happens is, after you identify the base is B in both of them, the other two kind of just switch spots. The C is going to be by the B in this case. It's going to go by itself over here. The A is by itself over here. It's going to go by the base when you rewrite it. Okay, so you always identify the base first, and then the other two values are going to switch spots related to the base. All right, so that's what we're going to be working with here at the beginning is understanding how to switch those back and forth. And again, there's not a whole lot of math to it. You just have to remember the pattern for these. So here's our statement again. So let's take these two statements here. And for the first one, we're going to change, and we're not going to do any math. We're just going to rearrange it. But notice it is in exponential form. You've got 2 raised to the exponent of 3 equals 8. We're going to rewrite it into logarithmic form. Okay? So we know it's going to go logarithmic form, so we're going to write log. And as I mentioned, we always want to identify the base first. What is the base in part A? It's the 2. The base always has the exponent attached to it, right? If it's an exponential form. So the base is the 2. So that means that's going to go down here. Okay? And then remember, the one that's by the 2 initially goes away, and the one that's by itself initially goes by the 2. So which one is by itself up here? The 8. So the 8 is going to come by the 2 when we rewrite it. And then we'll have our equal sign. And the 3 was by the 2 initially, but it's going to go, and it's going to be by itself when we rewrite this. And that's the pattern. That's all we do there is we just switch it from one form to the other. Okay? So let's look at part B. Again, same idea. We're going to write it in log form. What's the base this time? 3. So our base of the log is 3. The one that's by itself is? 1/27. So it's going to come by the 3. So 1/27 goes right here. And then we have our equal sign. And then what's going to be on the other side? -3. Okay, and it's that same pattern every time. So again, just to recap, identify the base first, because that doesn't change. The base of one is the base of the other one. And then the other two are going to switch spots in relationship to the base. The one that was by itself is going to come by the base. The one that was by the base is going to go over and be by itself on the other side of the equal sign. So again, the 2 was by the base. It goes over here by itself. -3 was by the base originally. It's going to go over and be by itself when you rewrite it. Okay. So does that first example make sense? All right. And there are our answers, which we already knew were right because we're experts, or we're going to be experts, hopefully. Okay, now what's the difference? What am I asking us for this time? To change it from logarithmic form back into exponential form. Or, sorry, yeah, into exponential form. So, what do we always identify first? And what is the base of this one? 10, right? Subscript is a 10. So now this time it's the base for an exponential. So we write our 10. What needs to go by the 10? 5. The 5, because it was originally by itself, and now what's going to be by itself? 100,000. Okay. Does that make sense? All right. Now the next one here has some variables in it, but we do it the same way. We start out by identify the base. And what is the base? 5. So 5 is the base. And then what's going to be the exponent for that base?
R.
The R. That's right. Equals, and then what goes by itself? The S. Okay, so it's that same pattern regardless of which direction you're going. If you're changing from log form into exponential, identify the base first, the other two switch. Going from exponential to logarithmic, identify the base first, the other two switch. So again, it doesn't matter which way. The only thing that you do want to make sure of is if you're switching into logarithmic form, make sure that you write down log and then your base. If you're doing exponential form, you just go straight to here's the base. Okay? Does that make sense? So far, so good. Like I said, that's very, very important. We're going to be doing that a lot tonight. So don't forget what we just did because we're going to keep coming back to it. All right? So let's take a look at this one. This one says to solve log base 4 of x equals 2. Well, this is actually a very simple form of a logarithmic equation. We know it's a logarithmic equation because you're taking the log of the variable. The variable's like stuck inside the log. Does that make sense? All right. So here's what we're going to do. Anytime we see a logarithmic equation, we're going to change it from logarithmic form to exponential form, like we were just doing. And I'm going to show you what happens when we do this. So help me out. How do we change this from log form to exponential form? Identify the base. And you're right, that is a 4. And 4 to what power? 2 equals?
X.
X. Well, yeah, 4 squared does equal 16. But equals X, so we're setting up our equation. Okay? So we have changed it from log form to exponential form. Here, the X was trapped inside the logarithm, right? We couldn't do anything with it when it was trapped inside the logarithm. Because remember, our goal is to get that X by itself. We rewrite it, and look, all of a sudden, the X is by itself, which is exactly what we want. So now we're ready. What is 4 squared? 16. So that's solving for X. X is 16. Okay? And that is a key step. Anytime we see a logarithmic equation, that's what we're going to do. We're going to switch from from log form into exponential form. Okay, so just like we were doing on the last few slides. Any questions on that one? All right, so we get 16. Now we have 2 special kinds of logarithms. The 2 special kinds of logarithms, and if you look at your calculator, like I said, you're going to need your calculator, so you may want to get it out so you can find these buttons. The 2 special types of logarithms that we have are what are called the common logarithm, first of all. And this is a logarithm that has a base of 10. A base of 10. Now, when you have a base of 10, because it is a common logarithm, almost always you will see it written like this. Notice you don't see the base written, do you? All right, it just says log of X. So when you don't see the base written, automatically that is base 10. Now I know I did an example right back here where I had the base 10 written, just to emphasize it was base 10. You probably won't see that again in this class because automatically from this time on, if we see log of X, that automatically means base 10. All right? So that's a special one, so it gets its own special abbreviation. Now, if it's anything other than 10, there will be a base number written there. Now, here's the other special one. The other special one, and I think we talked a little about the E thing last week, right? The other special one is the natural logarithm. This is a logarithm with a base of E. Right? And when we write that, you don't write log, you write ln. So ln of X means log base E of X. That's another abbreviation. So this one automatically means base 10. This one automatically means log base E. And if you look on your calculator, you're going to see a log button. That means log base 10. You're also going to see an ln button, which means log base E. Is everybody able to find those on their calculators? Anybody having trouble? Let me rephrase that. Anybody having trouble finding them? I can come and help you find them. Okay. So those are 2 that you won't see an E written down here. You won't see a 10 written down here. Those are the 2 that we automatically know are like that if you see a log or you see ln. Okay. So grab your, oh no, wait, this is not a calculator one. So this says evaluate log of 1,000 using the definition of common log. Okay. So log of 1,000, I'm just going to copy that down. Now we know that this is base what? 10, because it just says log, right? So I'll just put that in a different color here just to emphasize, but we know it already because that's what we just learned on the previous slide. And if you remember, we had some cancellation properties that were on like the very first slide. And here's how we're going to do a problem like this. Does anybody know? Well, let's see what we remember here. 10 to the first power is what? 10. 10 to the second power is what? 100. 10 to the third power is 1,000. And that's the one we've got here, right? 10 to the third power. So see if this makes sense. Does it make sense that I can replace the 1,000 with 10 cubed? Okay. Now, what was the base down here? 10. I'm going to go back because I want to remind you, I didn't just make this up. This was on our notes. If you look back a little bit higher. Remember what happened when we had the bases that were the same? What happened with those bases? They canceled out, and all that was left was that exponent. So now let's go back. Well, actually, it's right here. But right here, notice here's your base of the log is 10. Your base of the exponent is 10. So what is this going to equal? 3. So if we can write it so that those bases are the same, that's really convenient because they just cancel out and we get whatever that exponent is. So we can use our cancellation properties in some cases. Now, we can't use that all the time because we can't always make it a base of 10, right? They're not always that easy. But that's...
So you brought down the 10 as well, even though 10 to the third power is 1,000, right?
Okay, say that.
You still brought the 10 down, even though you replaced.
Are we talking about this or this?
Yeah, the other one.
This one?
The first one.
This one.
You brought it down, but 10 to the third power is 1,000. So you still bring it down even though you do that?
So I'm not
Sorry,
sure.
I don't know.
That's okay. I'm not sure I'm understanding the question, but all I was doing was showing you that this statement was exactly the same as this statement because all we switched was the 1,000 into 10 cubed.
Sorry, yeah.
Does that make sense?
Yeah. No,
Okay. Did that answer the question
Yeah,
though?
sorry.
Okay. All right. I wasn't sure if I was answering the question or not. You're tired. All right. So does that make sense that sometimes we can write it and we can use our cancellation properties or our cancellation property? All right. So because of that, log of 1,000 is 3. Now, you have a calculator and you have a calculator that has log base 10 on it. So go ahead and type in to your calculator log of 1,000. And it shouldn't surprise you that what do we get when we type in log of 1,000? We get 3. Make sense? I wasn't lying to you. It really is 3. But that's why it's 3. But your calculator will do log base 10. Your calculator will also do log base E. Yes, sir.
I don't know if I typed it in right or not.
But if you did get 3, you didn't type it in right. Let's see. What did you do?
Well, I just did,
Yeah. Oh, that's natural log. That's probably not. You want to do, you got to do this log. So you've got 2 logs on the same. You have to push it right? Okay. So, whoops, sorry. Now put in your 1,000 and you should get 3. Got it? Yeah, some calculators work differently than others. So as long as you know how to use yours, that's the key. Okay. Was everybody able to get the 3 when they typed it into their calculator? She's like, I just got here. I don't know what we're typing into the calculator. Do you have your calculator? If you do, or when you get it out, go ahead and try and type in log of 1,000. Oh, actually, you did. You don't need the shift. I'm making you nervous by standing here. So that's all we did it. We did it using a cancellation property, which you can watch the video and kind of see that beginning part. But we did it using a cancellation property, and then we showed, well, since we have that on our calculator, we can also just type it in. All right.
I mean, every day.
Are you digging yourself into a hole?
No.
Oh, okay. Now, how about this one? Natural log of e to the 1/2 power. What do we think about this?
You plug it into the calculator.
You actually could, but we don't need to. Why? What's the base of this logarithm?
Ln.
E.
What's the base?
Oh, it's it.
Nope.
No. E.
Ln is automatically base e. I heard somebody saying it, and you're correct. It's base e when you have ln, right? Back here, this is base 10. This is base e. Okay, do you see the difference? Log, if there's no number, is base 10. Ln, there will never be a number by it. It's always base e. Okay, so base e, what's the base here? E, what's going to happen?
Cancels out.
They're going to cancel out. What's the answer?
1/2.
1/2. Right? I can tell you a little hint about on the test. There are some questions like that on the test. So make sure you understand the cancellation properties. Yeah. Anytime, and this is, it's earlier in the notes, but anytime the base here and the base here are the same, they just cancel out and the exponent is all that's left. So this one, and you missed this part.
Oh, sorry, I don't see.
Yeah, you don't see a base e. ln automatically means, if we go back to this one, this natural, it's called a natural log. It has a base e automatically. When you see ln, it's automatically base e. So if you were going to write it out like the long way, you have to write log base e, but you'll probably never see it that way because you just write it this way. So it automatically means base e, and then we can use that cancellation because those are both e's for the base of the exponent and the base of the logarithm. You have the notes, right, or no?
I do.
Okay.
I do on the-
No, okay. Did everybody have the notes? I do have one extra copy. I think I've got everybody the notes now, though. I think. All right. So 1/2. Everybody okay with that cancellation property?
Yeah.
Okay. Now, here's one that we can't just use a cancellation property with. We're going to use the calculator. So go ahead and type that into your calculator. Log of 500. Now, I'm going to ask you a question. What is the base? 10. Automatically 10, right? If there's no number written, 10. So
So the calculator
the
should know that.
calculator knows that automatically.
So it's 2.698.
Yep, probably. I don't know. I didn't type it in, but
Yeah.
2.699 if we round it off. Okay. And again, on the homework, they usually will tell you like round off to 3 or 4 decimal places. So just follow the directions there as far as how far to round. Was everyone able to get the 2.699?
Yes.
Yes, got it. All right, good. Okay, so we have some properties of logarithms that we're going to use when we get to the equations. And so here's the first one. Actually, this is the one we're going to use in this lesson because we use it to help us solve exponential equations. So notice what we've got here, log base b of a raised to the r power. Notice what we have over here, r times log base b of a. What has changed?
There's a letter in front of.
There's a letter in front and it's multiplied. Where did that letter come from? Yeah, it used to be the exponent. So our property is, if you ever have log of a number with an exponent, that exponent can be moved down into the front of the logarithm. It's a property that logarithms have because, let me go back, because, oh, actually right here. Because logarithms, see how this says log base b of c equals a? Logarithms are actually equal to exponents. Do you see that? If log base b of c equals a, and a is the exponent, that's what logarithms are equal to. They're equal to exponents. So you don't have to really remember this a whole lot, but they follow the rules of exponents rather than following the rules for normal numbers. And exponents have different rules. You remember way back at the beginning of the year, we said if you have x squared times x to the 5th power, what do you do with the exponents? If somebody said it, but I want to make sure I write it. If you have x squared times x to the 5th power, and somebody said it, what do? You add them, right? So the exponents get added together. They don't get multiplied, right? The whole number is multiplied together, but the exponents get added. And so they have several, exponents have several rules like that where they do something a little bit different. If you remember when we divided, what did we do with the exponents? Subtracted them. And if you had one base that had 2 exponents attached to it, what happened then? Anybody remember? That was the one we probably used the least, but you multiply them. Okay, and that's the rule. Let me get back to where I was. All this going back and forth. It's a good thing it doesn't spin or we'd all get dizzy. Okay, but that's the rule actually that we're using here. We've got the base is b, and then it's like these are 2 exponents attached to that b, so this exponent gets multiplied by the logarithm because those exponents get multiplied together. Okay, and that's, again, you don't have to really remember why it works. You just have to know that it does work, but the reason is because they're exponents. Okay, so when we see something like this, tonight especially, we're going to take that and we're going to move it out into the front so that it's going to be r times the log base b of a, whatever that happens to be. Now here's why we do that. Oh yeah, I'm going to rewrite this first. I forgot I was going to switch this problem, but then I'm like, well, their notes aren't going to be changed, and so I'm just going to change it tonight. So this we're going to write as log base 3 of x squared. So change this example to log base b of x squared. I mean, it would be 5 squared, but with a number, there's no reason to do that. So I'm going to make it an x squared. Now, using our exponent property that we just learned on the previous slide, what are we going to do with this statement right here? How are we going to rewrite it? We're going to make the 2 go to the front. And so it's going to be 2 times log base 3 of x. That's what our exponent property says. Okay? It says if there's an exponent, we can take that exponent and move it out into the front. Does that make sense? Are we okay with that? Yeah, so just cross off the log base 3 of 25. I'm going to change that. I'll have to try and remember to change it now for the next time, if I don't forget. All right, but are we okay with that property? The exponent, if there's a logarithm, the exponent can just move out into the front. That only works with logarithms because they have this special property. Okay, so don't worry about that. Just pretend that 5 is an x. All right, how about this one? This one we're using the same property, but notice that this one is written differently. There's no exponent here, but do you see that we have 4 times natural log of x? So what could we do with that?
X to the power 4.
Yeah, we're actually going to take this 4, and we're doing the reverse this time. We're taking that 4, and we're going to move it back up to the top. You see how that's the same thing, just in reverse order? Like last time we took this and changed it into this. This time we're starting here and changing it back into here. Now you may wonder, why do we have to know how to do both of those? And the reason is because, and we're going to learn this more in the next section, but the reason is because there are certain times when we want just one logarithm. And we want everything like squished together into just one logarithm. And then there's going to be other times when we want those logarithms all broken apart so that what we're taking the log of is as simple as possible, like just an x or just a y or just whatever letter. Okay, so we're going to be practicing tonight, especially in our next unit, our next section, breaking these logarithms apart so that they're as simple as possible, even though there are multiple logarithms, but each one is really short, and also putting them together so that it's one logarithm with a whole bunch of stuff inside of it. Okay, but that's what we're working on here. For this section, really, this is going to be our main one. Take this thing, move it down in the front. Okay, so we get that. We already had that. The other thing we want to talk about before we get to some equations, the change of base formula. Most of your calculators have a log button and have an ln button, but they typically do not have other bases. Now, what I'm saying here is kind of out of date because some of your calculators probably now do have other bases where you can change the base. It used to be, it was just log base 10 and log base e. That's all that calculators had, log and ln. So what we had to use is we had to use this. If we want to calculate or figure out with our calculator something with a different base, we can use what is called the change of base formula. And so we can rewrite this logarithm right here, log base b of a, as log of a over log of b. Now, I'll just tell you, in general, this works for any log. That's why you see this c here. But the way we're going to use it is like this. Log base b of a equals log of a over log of b. We're just going to use log base 10 because we have that on our calculators. Okay? Now, here's how we remember this, besides putting them on our note cards. But here's how we remember this. The a and the b, compare them. Which one looks like it's higher? The a. Which one goes on the top when we rewrite this? The a. Which one looks like it's lower? The b. Which one goes on the bottom when you rewrite it? The b. Doesn't that kind of make sense? The top one goes to the top, the bottom one goes to the bottom. Okay? So when we want to evaluate something like this, we can just rewrite it in log form. So again, this is probably this one, not necessarily this one, but this is probably something you want to circle and make sure you put on your note card for when we take our test. Okay, so what we're going to do now is we're going to use that property with our calculators to evaluate log base 2 of 10. So if I'm going to rewrite it using that change of base formula, what am I going to put on the top? Log of 10. And log of 2 on the bottom. That's correct. Does everyone agree and understand why? The 10 looks like it's higher, it's going to go on the top. The 2 looks like it's lower, it's a subscript, it's going to go down on the bottom.
So is that the answer? Or
We're going to type it into the calculator and get a number.
where are we typing?
This part.
So it will let us
Yep.
type that in.
Yep. So here's what we're going to, here's how we're going to do it. Yep. Here's how we're going to do it. Most of your calculators, and again, there might be some differences, but most of your calculators will automatically put, after you type log, it'll automatically put like a parenthesis there before the 10. What you're going to want to make sure that you do after you type in the 10 is you want to close the parentheses. And then you're going to push your divided by sign. Or if you have a fraction, I guess you might, depending on your calculator, you might be able to use fraction. I just always use divided by. And then when you put log on the bottom, it's going to put the parentheses there again. And just like we did after the 10, we're going to close our parentheses after the 2.
So it should be
3.32. Is everybody getting 3.32? 3.322. Does that make sense? Was anybody not able to get that? Okay. Did you get it? Oh, yeah, don't use the fraction button, use the divided by sign. These calculators don't like you to use the fractions yet. So try the divided by. Did you try to use the fraction button also?
Oh yeah, I used to.
Okay, so go ahead, log of 10. So it's when you round this 9 makes it 1. Anybody else? Everybody okay? Cheats?
No, mine doesn't work.
Oh, it doesn't work?
Well, I mean it works, but like mine doesn't do the parentheses.
Oh, it doesn't. Okay. So let's see. Oh, okay. So here's what you have to do on your list. Let me think, because you have to type it in a slightly different order. Okay, so you're going to do 10 first. And the thing that pushes the log button, divided by, and you're going to type in 2. So you got to type it a little bit different. So different calculators, like I say, different calculators work different.
I was doing it right.
Oh, okay. No, it was, you're just one step away. Yeah, that's equals at the end. All right. Okay, anybody else? Anybody else good? Okay. Okay, go ahead and try this one. Log of 100, log base 5 of 100. So how do we want to rewrite this one?
100 equals log 100 over 10 or log 5.
Log 100 over log 5, correct. And then make sure you put your parentheses in if you need to, in the correct spot. And once you get an answer,
2.8.
2.86. Now, here's what this means. Remember, logarithms are exponents? This means 5, and we rounded this off, but 5 to the 2.86 power, 2.861 approximately, is equal to 100. So if you try that on your calculator, try 5 raised to this power. Now, again, we rounded this off, so you're not going to get exactly 100, but you should get something really close to 100 so that you can say, oh yeah, this is right. We just had to round it off. Did you get something really close to 100? What'd you get?
99.
99.9, and you had
191.
191?
Yeah. Wait, what do you want to do?
Just 5 raised to the 2.861 power.
Oh.
2.861 is what we rounded it off to.
Oh yeah.
And you got something really close to 100, right?
Yeah.
Okay. So just remember, that's what logarithms are, is they're exponents. You're figuring out, if I have this base, what power do I have to raise it to get this number? That's what logarithms do. They ask you for, what's the exponent that we need? It's really hard to figure that out, so it's good that we have calculators to do it for us. Okay? Are we okay with that? All right. Here's our rules for solving exponential equations. Now, this may be confusing because exponentials was what we were doing last week, right? And where was the variable in an exponential equation? In the exponent, right? In all those problems you did last week, the variable was up in the exponent. Whether it was a base of e or a base of 5, or it doesn't matter, but the variable was always up in the exponent. That's what made it exponential. So when we talk about exponential equations, your variable is going to be up in the exponent. That's what makes it exponential. Okay? So first step, when we do really either of these types, but especially exponential, we're going to isolate the exponential expression. That means the base and the power will be on one side of the equal sign, and everything else will be on the other side. Okay? Remember how usually we get the x or the variable by itself? In this case, our first step is just to get that base and exponent by itself. So that's step one. Sometimes it's already done for us, but that's our first step. Then here's the key. We're going to take the logarithm of both sides of the equation. That's the key step here. Because after we do that, we can use the property that we just talked about, and we can move the exponent out into the front of the equation and have whatever times logarithm. Okay, remember this property right here? Where is it? Here it is. This is the property right here. We're going to take that exponent and move it down in the front. Because what's in the exponent? The variable, right? We don't want the variable stuck up in the exponent. We want to get it down where we can work with it. And so that's why we do this. So back to here, our steps are isolate, take the log of both sides, then use our exponent property to move that exponent out in the front. Okay? Once that exponent is out in the front, that variable is out in the front, then we can just use normal algebra to solve the equation. Adding, subtracting, dividing, multiplying, whatever we need to do. Usually it's division. Usually it's division first and then maybe something else. But pretty much always division first. Okay? So those are our 4 steps. So let's see those steps in action. That was already filled out on your papers, right? So you didn't need to write that down? Okay. Let's see those steps in action. So here's our equation. Right there. Notice the base. Well, first of all, notice where the variable is. Up in the exponent. That's what makes it exponential. Okay. And then notice the base and the exponent are by themselves, and then you have your equal sign and 10. So it's already isolated. That part's done. So then what was step 2? You can look if you need to. It's totally fine. Take the log of both sides. So we're going to have log of 2 to the x power equals log of 10. So we're taking the log of both sides. That's the only thing we do, log of both sides. Okay, is everybody understanding what we did there? Now here's why we do it. Because our next step is, according to our property, what can we do over here on this side? We can take this x and move it down in the front. So now it's x times log of 2 equals log of 10. And if I'm trying to get this x by itself, and it says x times this thing, I want to get rid of this, right? Because I'm trying to get this x by itself. How would I get rid of this? If it's multiplied, we divide. So we're going to divide by log of 2. Remember that's all stuck together, log of 2. So you're not just dividing by log or just by a 2, it's log of 2. And I think we already actually did that. What is log of 10 divided by log of 2? Nope. You have to put in your calculator.
Oh,
you can't cancel.
Okay.
Yeah, we did that one already, right? Earlier when we were doing the change of base formula. Okay. So we happen to get the same answer, but that's the process we use on all these exponentials. Okay. Any questions on that? So 4 steps. The first one was done already, right? Isolate it. Second one was take the log of both sides. We did that right here. Third one was move the exponent out into the front. And then the last one sometimes takes more than just one step, but our last step is do whatever math we need to get that x by itself. Okay, whatever algebra we need to do. Okay, let's go on to the next one. So first question, are the base and the exponent isolated? No. What's there? The 5. We've got to get rid of the 5. How do we do that?
Divide.
Now we're trying to get rid of it. We're trying to cancel it out.
Oh.
So we want to divide because it is multiplied by the base and the exponent, right? So this is 5 times. If we want to get rid of it, we divide. So the 5 cancels, and now we have 0.93 raised to the x power equals 2. If it comes out nicely, just simplify it. If it doesn't, leave it as a fraction. Doesn't matter. Now, is it isolated?
Or yes.
Yes, base and power are isolated. So what is our next step?
Log.
Take the log, before that, take the log of both sides. So log of 0.93 to the x equals log of 2. Now we're ready for your step, Antonio. Now we can put the x in the front. Now that we've got the logarithms there, now our property says we can take this x and move it to the front. So it's going to say x times log of 0.93 equals log of 2.
We need to divide by 0.93 on both sides.
Not just 0.93.
Or log.
Log of 0.93. Yep, because that all is stuck together. So in order to get rid of it, we got to get rid of the whole thing. So divide by log of 0.93 or 0.93, either way. That cancels, and we're going to get x is approximately what? I think it's is it a negative number this time?
Negative 0 or negative 0.104.
That? Yeah. Nothing in front of the decimal point?
No.
Okay.
0.
Yeah, 0. Oh wait, that's not what I got.
That's what I got.
Okay, let's double check. It's probably just something you typed into your
No,
calculator.
I put it the wrong way.
Oh.
I put it upside down.
Okay. Oh yeah, that would make a difference.
Not bad.
So try it again. Log of 2 divided by log of 0.93. Did you get it now?
Oh, I mean, I didn't type it in.
Oh. I just want to make sure that you are able to get it. Okay. Now, if we wanted to check this, remember how sometimes you want to check your answers, like on tests, some of you are very like, I got to check my answer, make sure I have the right answer. Do we see how we could check this? We would type into our calculators 5 times 0.93 raised to this power. And what should it equal? It should equal 10. Now, remember, we had to round this off, so it's not going to probably equal exactly 10, but it should equal something really, really close to 10, like 9.998 or 10.002 or something like that. But it's going to be really close so that you know, yeah, that's the right answer, but we rounded off. Does that make sense? Okay. So any questions on how to solve that one? Isolate, log of both sides, bring the exponent out in the front, and then solve for that variable. Okay, let's do another one. This one's a little bit trickier because why? There's a number with the x. All right. So we got to pay attention here. First question is, though, is it isolated? No. What do we have to get rid of? Divide by 5. So that cancels. We have 1.07 to the 3x power equals 2/5, or that one comes out nicely. It's 0.4. So you can leave it as a fraction 2/5, or you can put 0.4. It doesn't make any difference. Then what do we need to do after we've isolated? Log of both sides. So log of 1.07 to the 3x power equals log of 0.4. Then we can use our property. And our property says we can move this 3x out in the front. So 3x times log of 1.07 equals log of 0.4. Yes, I want to pause here for just a second to make sure everybody's caught up. But you're right. You're right. He's in the zone.
I'm in the zone.
He's trucking.
'Cause I feel like I know what to do.
Okay, so is everybody caught up and okay with what we've done so far? Okay, so now what are we going to do next? Yes. And that cancels this out. So now we have 3x equals log of 0.4 over log of 1.07. Okay? What is our last step here now? This one had an extra step, right? How do we get this x by itself? Divide by 3. So if we divide by 3 over here, we've got to divide by 3 over here, but it can get a little messy. So I'm going to actually put it over here with our old-fashioned divided by sign, right? And here's how I would suggest typing this into the calculator. Type this into the calculator first, get your answer, and then divide by 3.
Or -4.51.
I don't know what the answer is. We'll find out in a second. But is that what everybody else is getting? Or
I mean, I just clicked onto the side.
I think it looks good.
Yeah.
There you go. Okay. So I would suggest, because different calculators will do this slightly differently. You can do it all at once with a bunch of parentheses and extra stuff. But if you just do this part first, like we've done before, and then take that answer and then divide by 3, then you're good.
I'll take a picture of this.
Go for it. I'll get out of the way. I don't want to blemish your picture.
Not enough room
On your
on the paper.
on the paper. Yeah, like I say, I try to get all the examples on there so I don't have space for you to put your work. So you may have to bring like a separate sheet of paper or something. But okay, does this make sense? How we did it?
The log divided by the.
This
other
one?
log,
This
you
one?
have to put the highest number on top, or is it the way that?
It's whichever one is on the top. So what we had was we had this, and in order to cancel this out, we had to divide by log of 1.07. So that's what we have to divide by 1.07 here. So whatever it says, log of 0.4 divided by log of 1.07, that's the order that you do it in. It doesn't have to be the bigger one on top, smaller one on the bottom, or anything like that. You just whatever it says. Any other questions? All right, that's the end of section 4.3.
We don't go for 2.
We're not doing 4.2. 4.2 is graphing. Do I have 4.2 in there? Okay, I didn't think so. 4.2 is graphing, and we're not going to worry about the graphs.